Welcome to all of you who joined us today on OECD's Green Talk Live. Maybe we can get started. Well, some additional people I see that they're just connecting online, but maybe I can just get started because we only have 1 hour actually, and we would like to be able to cover quite a lot of ground. So I'm Kumi Kitamori, Deputy Director at the OECD's Environment Directorate. Today, we are launching our new report, our latest report, Mainstreaming Biodiversity into Renewable Power Infrastructure. So as we know, the world is facing the twin crises of climate change and biodiversity loss. We all know that both have severe implications for human health, societal well-being, and the economy, and both require a much faster and more ambitious policy response. Last year was the warmest ever recorded year in human history. The window for keeping the Paris Agreement 1.5 degrees Celsius temperature goal within reach is rapidly closing, and actually even faster than scientists had earlier thought. And at the same time, our biodiversity continues to decline. Since 1970, populations of wildlife have declined on average by some 69%. And many ecosystems are degraded, leading to decline in critical ecosystem services such as pollination, water filtration, and flood protection, to say the least. Now, these two crises, climate change and biodiversity loss, are closely interlinked. The one exacerbates the other. And that means that efforts to tackle biodiversity loss and climate change tend to be mutually reinforcing. So that's good news. But conflicts and trade-offs may also arise. This is increasingly evident in the expansion of renewable power infrastructure. Now, failure to consider biodiversity in renewable power projects has already adversely impacted species and ecosystems. And it has also resulted in renewable power projects being halted or delayed or canceled. One of the key outcomes of the climate COP28 was a commitment to triple renewable power capacity by 2030. The IEA's modeling shows that this is critical for achieving the 1.5 degree goal. So a key question for today's discussion is, how can countries fulfill their mission under the Montreal Global Biodiversity Framework to halt and reverse biodiversity loss by 2030, while at the same time tripling renewable power capacity? And the OECD's new report, Mainstreaming Biodiversity into Renewable Power Infrastructure, provides some answers. This new report reviews the impacts of solar power, wind power, and power lines on biodiversity, and presents good practices and tools for mainstreaming biodiversity into power sector planning and policy. With most renewable power infrastructure yet to be deployed, we have a considerable opportunity to develop power systems that deliver better outcomes for both climate and biodiversity. I believe this report provides government planners, regulators, and environmental policymakers with valuable guidance on how to protect our species and ecosystems as we scale up renewable power capacity. So to present the key findings of this report, we are joined by its author, Edward Perry, that you see on the screen. And he's a biodiversity policy analyst in the OECD Environment Directorate. After his presentation, we will hear some reactions and insights from two discussants. I'd like to extend a very warm welcome to Mona Khalil. She's Energy and Wildlife Program Specialist at U.S. Geological Survey, and also Floor Kleemans. She's Policy Advisor on Nature in the Ministry of Agriculture, Nature and Food Quality in the Netherlands. So after these interventions, we will then open the floor for discussion with all of you online today. So those of you online, you can send questions anytime during the course of the event using the Q&A function, which I hope you see at the bottom of the screen. And then we will try to address as many of them as possible in the time that we have available. So without further ado, let me pass the floor over to Edward, who will present the key findings of the report. Over to you.
Thanks very much for that introduction, Kumi, and hello to you all online. Thank you for joining us today. Let me just pull up my presentation. Can you see that okay now? Yes, great. Great, so it's my pleasure today to present some key insights from our latest report on mainstreaming biodiversity into renewable power infrastructure. We'll get there. Today, I'll provide a brief overview of some of the impacts of renewable power infrastructure on biodiversity and talk about some of the key steps governments can take to safeguard biodiversity as we scale up renewable power. But let's start at the beginning. Why is this work important? All pathways consistent with achieving the Paris Agreement temperature goals see electrification of our energy end uses and an increase in low emission sources of electricity. In IEA's net zero scenario, consistent with the 1.5 degree target, the share of electricity in final energy increases from around 20% today to over 50% in 2050. Now, the share of renewables in electricity generation increases from around 30% to up to 90% in 2050. And the majority of this comes from solar PV and wind. Together, solar and wind account for together, solar and wind, the capacity of solar and wind will increase by about fourfold by 2030 and 13-fold by 2050. Now, scaling up renewable power is not only critical for achieving the Paris Agreement targets, it is also vital for achieving the mission of the Kunming-Montreal Global Biodiversity Framework to halt and reverse biodiversity loss. Climate change is a key driver and fast-growing driver of biodiversity loss. However, renewable power infrastructure is not environmentally benign. It too can pose a risk to biodiversity. As renewable power expands, we're going to see increasing interactions between biodiversity and the power sector. Already today, large-scale hydropower, wind, and solar facilities are either operating or being built in close to 900 protected areas, 749 key biodiversity areas, and 40 wilderness areas. 1/3 of areas with high solar and wind power potential have overlap with areas of high biodiversity value. So without proper planning, there is a risk that this expansion will harm biodiversity. And not only that, in doing so, in degrading ecosystems, expansion of renewable power without strategic planning could also actually compromise our efforts to achieve climate goals. For example, if solar and wind were to be sited where resource potential was its highest, then approximately 11 million hectares of natural lands, that's about the size of Bulgaria, could be converted. And this would release around 450 million tons of carbon stored in plants and soil. So it is in this context that we have delivered this report to help align climate and biodiversity action. The report aims to increase understanding of the impacts of renewable power on biodiversity and to provide governments with some good practices for integrating biodiversity considerations into power sector planning and policy for renewable power. The report looks at solar photovoltaics, PV, and concentrated solar power, looks at offshore and onshore wind, and infrastructure for electricity transmission and distribution. I'll refer to these collectively as renewable power infrastructure. The report does emphasize the importance of considering the full life cycle impacts of renewable power infrastructure. So including the impacts from the increasing demand on mineral resources, but it's primarily geared towards helping governments mainstream biodiversity into power sector planning and policy around the construction, operation, and decommissioning of these energy facilities. Renewable power can impact biodiversity in various ways, both terrestrial and marine biodiversity. And these impacts depend on the type of infrastructure and its design, where infrastructure is located, and how it is constructed, operated, decommissioned, or repowered. Examples include direct species mortality, for example, from collision or electrocution, habitat loss, degradation and fragmentation, displacement of species and behavioral or physiological changes, habitat creation, invasive alien species, ecosystem service impacts are just some of the examples. Can also lead to indirect impacts, potentially. Now, this is poorly studied, but could include things like the impacts of for example, fishing or agriculture or tourism. If that's displaced in one area by renewable power developments, what impact does that have elsewhere on biodiversity? The impacts are mostly negative for biodiversity, but there are also positive impacts. For example, in solar facilities in the UK, studies have shown that the species diversity and abundance was actually greater at solar fields where they were applying good practices for biodiversity compared to the surrounding brownfields or agricultural land where those solar fields were deployed. Key concerns are really how these impacts may accumulate over time, how the impacts combine with impacts from other renewable power facilities and other human pressures, how these impacts may scale with renewable power expansion, and what the effects might be on species populations. And these are very difficult questions to answer, as I'm sure we'll hear from Mona. But what we do know is that some species are particularly sensitive to renewable power development. For example, raptors, large migratory soaring birds, and some bat species have an elevated risk of collision with wind turbines. And their populations are also highly sensitive to additional mortality. And that's because they have long lifespans, low reproductive rates, and late ages of maturity. So life traits that make them more susceptible to additional mortality. In the US, studies have suggested that at current estimates of mortality, collision with wind turbines is perhaps not going to be leading to population level impacts for many of the affected birds, but could already be affecting the populations of some raptor species. Experts think that the impacts, that the effects on bat populations could also be leading to declines, but bat populations are not as well studied. So this is a clear area of focus in terms of strengthening the evidence base, understanding the cumulative and population level effects. The report also shows that the knowledge base is uneven. It's uneven across technologies, species, ecosystems, and geographies. For example, we know much more about the effects of onshore wind on terrestrial ecosystems and offshore wind on marine ecosystems. We know relatively more about what the risk factors are for non-avian species than other species. And much of the information and data is coming from Europe and North America. There's less coming from developing countries where much of this renewable power is expected to be built. It's not all doom and gloom. We do have solutions to help mitigate these impacts from renewable power on biodiversity. These range from smart siting of infrastructure to also changes in the design and operation of infrastructure. For example, infrastructure designs to reduce electrocution risk, or applying biodiversity-friendly mowing or grazing to maintain vegetation around solar panels and solar facilities. Digital technologies and things like artificial intelligence are providing new opportunities to cost-effectively monitor and mitigate some of the impacts on biodiversity. And an example of this is automated shutdown of wind turbines when sensitive bird species are identified crossing the path of those wind turbines. And these measures can be effective. For example, increasing the cut-in speed of wind turbines to 5 meters a second, that is the wind speed at which the turbines start turning, could reduce annual bat mortality by up to 79%. But we really need to have more targeted research and standardized monitoring to better understand and refine the effectiveness of these measures. Governments, through strategic planning, can greatly reduce the risks to biodiversity. At the strategic planning level, this is the stage where governments make decisions on the types of electricity generation technologies and where they will be located. And these decisions have important implications for biodiversity. In our report, we identify some of the options governments can take for mainstreaming, some of the opportunities for mainstreaming biodiversity into power sector planning. I'll just touch on a few of these right now. So firstly, energy planning models. These are models that inform decisions on capacity expansion, on which electricity generation technologies to invest in. By integrating spatially explicit biodiversity data into these models, planners can better identify portfolios of technologies that are socially optimal, that are low cost, low carbon, and low risk to biodiversity. Spatial plans or renewable energy zones is another key entry point. By developing these plans based on biodiversity data, governments can steer renewable power developments away from high-risk areas like key biodiversity areas, migratory routes, foraging areas, other sensitive areas, and towards lower risk areas. Now, these spatial plans can also be informed or supported by tools such as sensitivity mapping, environmental sensitivity mapping, or wildlife sensitivity mapping tools, such as I think BirdLife International's Migratory Soaring Bird sensitivity mapping tool, and the Site Renewables Right tool, which you see here on your screen from the Nature Conservancy. So this can both inform the spatial plans or help projects in their early siting decisions. The third point I wanted to raise is the fact that governments can make much better use of strategic environmental assessment and cumulative impact assessments when assessing, when appraising their power sector plans and policies. It's very much at the strategic planning level that cumulative impacts can best be understood and addressed. we're also seeing that some planners, some governments use tools such as multi-criteria decision analysis and cost-benefit analysis to help inform the decisions, to help better understand the potential trade-offs across different policy objectives and come to socially optimal choices, for example, in grid expansion. And there's scope for more use of such instruments, but also to integrate biodiversity and ecosystem service values into those decision support tools. There are clearly opportunities for expanding renewable power with relatively low risk to biodiversity. First, to reduce the power sector's demand for land, governments can maximize the use of rooftops and other infrastructure for solar power panels. So integrate renewables into existing infrastructure. In California, for example, one study suggested that maximizing rooftop solar could reduce land use by up to 445 square kilometers by 2050. We should look to capitalize on already converted land, things like abandoned agricultural land and brownfields. So this is things like old mining sites or landfill sites. And just to give you a sense of the scale of this opportunity, sufficient converted land exists globally to deliver 17 times the required renewable power to meet the combined emission reduction targets of countries. And the third area is around co-location. So co-location provides an opportunity, co-location or multi-use spaces is an opportunity to perhaps reduce land use and also harness synergies across different economic uses. For example, integrating wind and solar facilities, and there's also some work, particularly in the US, on agrivoltaics as well. So some options there, some opportunities there for low risk expansion of renewable power. Mainstreaming biodiversity into planning not only is important for reducing risk to species and ecosystems, but it can also provide certainty to developers, regulators, and stakeholders. Early integration of biodiversity into planning is critical. For example, one study in the US found that siting solar areas of low biodiversity value could reduce project costs by up to 14%. And these cost savings come from the reduced permitting time and also the reduced need for mitigation measures had the facility been located in a more ecologically sensitive area. Now, strategic planning needs to be accompanied by an appropriate mix of policy instruments. Governments can leverage various policy instruments to encourage or require, incentivize renewable power companies and utilities to mitigate the adverse impacts of biodiversity and to seek positive outcomes from their projects. In our report, we identify and examine a range of regulatory, economic, information, voluntary, and other instruments that governments are using with this objective in mind. Now, some of these instruments, such as environmental licensing and permitting, are a common practice, but their application and effectiveness varies considerably. Other instruments, such as integrating biodiversity criteria into the assessment of tender applications, for example, is less common and but holds a lot of promise, I think, going forward. And we should hear, I imagine, more from Kleemans on that later. So a range of different instruments. What constitutes an appropriate policy mix will certainly vary from one country to another. But across the board, there is there are opportunities to scale up both the use and effectiveness of these instruments to safeguard biodiversity with the expansion of renewable power. Our report brings together these and many other key recommendations and policy options. So I'd encourage you to take a look. For further information, please visit our website. I think it's also on the Zoom chat. And I will leave it at that. Thank you very much, and back over to you, Kumi.
Sorry, having a bit of a technical issue. Thank you very much, Ed, for this quick overview. And the report is actually full of concrete real-life examples. So I really encourage everybody to get a copy and have a look for yourselves. Now, I would like to now turn to Mona Khalil. She's the Energy and Wildlife Program Specialist at US Geological Survey. So, Mona, we all know commitments can be tracked without measurement and monitoring. And one of the report's recommendations is to strengthen the quality and transparency of data on biodiversity and renewable power interactions. So from your perspective, what roles do data and science play in aligning renewable power and biodiversity objectives in the US? Are you seeing demand from industry for more biodiversity data? Over to you, Mona.
Yes, thank you very much. This has been a great interaction between the United States and OECD. I wanted to thank OECD and the Environmental Directorate for preparing this important report, for shining a light on this issue, which has been, for me, my entire job at the US Geological Survey, but also working with a lot of organizations across the United States. So we're a science agency. The US Geological Survey serves the information needs of the Department of the Interior, which is a government agency. And from the US perspective, the science-based approach, which includes studying how biodiversity is changing, how it's impacted, and specifically monitoring the trends of species, a variety of species across time, over long periods of time, is really critical for deciding how renewable energy development should be expanded across our landscape, which is very large, as you know. So it guides us on how renewable energy can be deployed, but also how biodiversity protection goals can be achieved given the different demands that are being placed on the landscape. So the scientific process motivates us to understand the causes of some of the biodiversity declines. So it's really important to have rigorous studies that can really parse out what the different reasons for biodiversity declines may be in order for decision makers to make decisions with confidence. So I look at it at three different ways that data and science is really important. First of all, at a high level, data and science on biodiversity declines. Now, as biodiversity is becoming more visible for decision makers and policy makers, it justifies actually increasing focus on habitat conservation and restoration. So even though renewable energy is just one type of infrastructure development that humans are putting on the landscape, there are many other threats to biodiversity. We have, of course, climate change. We have invasive diseases, invasive species, wildlife diseases, other development that are all putting pressure on biodiversity. By having a scientific and data-driven effort behind all of those, we can really put these different stressors in context and measure the trade-offs, measure and figure out a strategy that might be effective and allow us to put levers where they might have a chance of succeeding. And so at the Department of Interior, we look at the different stressors and try to figure out what can we do. And as a result, the America the Beautiful initiative, which is our administration's initiative now, has really put a lot of focus on we actually need to conserve and protect areas, because we know that a lot of deployment of infrastructure like renewable energy is going to take place. And so protect and conserve is a really important key in figuring out what to protect and how to conserve those areas. Secondly, as Edward really talked about in his report, and I'm so glad you really looked at this in a comprehensive way, it is very important for developing policy that works at different levels, at the national level, at the state level. As you know, in the United States, many states have their own decision-making power, and at the community level, at the level of local governments. And so planning and siting decisions really depend a lot on what knowledge is available. And in a country as large and diverse, ecosystem diversity in the United States is really phenomenal. And we still have a lot of wildland areas and intact habitat. It's quite a challenge to actually map this diversity. So a lot of the research that we do at USGS is actually what feeds the types of maps that the Nature Conservancy is able to produce to prioritize sections of the landscape that are high biodiversity areas, that are hotspots, and that could be either protected or avoided. And then finally, a really exciting opportunity for sort of moving into this century of how we approach societal issues is doing integrated science that includes biologists and engineers, policymakers, all the stakeholders that are working towards a common goal to design smarter technologies that incorporate the biologist's point of view or their expertise, so that when we develop new technologies like a new generation wind turbine or marine generation technologies, energy generation technologies, or anything new that will come on the landscape, which is undoubtedly what will be happening, like more geothermal or new different kinds of hydropower. The possibilities are endless, really, is to incorporate that mindset that everything that we do will have an impact on the environment, and we have to engineer it with biodiversity in mind before it is actually deployed. I think one lesson we've learned was that we put infrastructure on the landscape and there are unintended consequences. No one, as Edward mentioned, some bat species can be harmed by colliding with wind turbines. No one expected that when that technology was being placed on the landscape. It was a big surprise that bats were impacted in the way that they are. And so even though we can't think of everything ahead of time, incorporating science, data collection, and expertise from ecologists, biologists early on is really key. And that's something that we're working towards with other agencies. And in terms of demand, for additional biodiversity data, I think organizations like the Nature Conservancy, governments, and others, and industry as well, absolutely need that biodiversity information, because renewable energy is expanding into new landscapes. There might be turbines in the southeast of the United States, which before a few years back, that wasn't considered really economical because of the wind resource. Well, as technology changes, as it becomes cheaper, as certain technologies become more available, that development is starting to go into places that haven't had maybe extensive studies, or new species are being exposed to the technology, which is definitely the case, for example, with offshore wind. And so we are learning from the different phases sort of deployment. As Edward mentioned, land, we know more about land-based wind than we do about offshore wind. So we're trying to see what we can take from land-based wind and in terms of lessons and apply that to offshore wind. And so as long as we're developing new technologies and putting them in new places, there's really need for good information. And with the science, it's always hard to keep up. You know, the technology moves really quickly, but it's really key for providing confidence to decision makers about the effectiveness of the technologies, about how they work, about their impacts. And so I'm really grateful for the effort that the United States is putting into understanding these issues. But I'm also hopeful that we can work internationally because, as you know, migratory species like raptors and many other migratory bird species, they don't know country boundaries. And so they might be impacted across different countries as they migrate through. So it's really important that we work internationally. Thank you.
Great. Thank you so much, Mona, for your insights and on the use of science and data and information in this context for decision making. So if we can, let us now turn to Floor Kleemans. So as I introduced earlier, she's a senior policy advisor for nature at the Ministry of Agriculture, Nature and Food Quality in the Netherlands. So Floor, in the Netherlands, in your country, there's been a long history of developing offshore wind power generation infrastructure, and there are ambitious plans for further expansion. So what measures is your country taking to help offshore wind expansion, making sure that this does not compromise protection of biodiversity? So let me hand over to you.
Yes, thank you. Good afternoon from the Netherlands. Thanks for having me. Thanks for organizing this talk. So regarding to your question, we do have a long history of offshore wind energy, and we've got big ambitions to expanding even more offshore wind energy in the future, to increase our renewable energy, to decarbonize our economy and become climate neutral towards 2050. But before focusing only on offshore wind energy, we're working on achieving achievable requirements for nature inclusive design as in the whole of society. And the way we're doing this, we have implemented or we launched something called, or translates as an agenda nature inclusive. And what this is, it is kind of an instrument which is being developed with a lot of different stakeholders, parties involved, governments, but also industry, social organizations, and so on, to come up with requirements that are realistic, achievable, but ambitious in regards to nature inclusive design, nature requirements. And it doesn't only focus on energy transition, energy projects, but it looks at a whole different kind of domains, from financial to agricultural to social aspects, behavior as well. And the goal of this agenda is to create a nature inclusive society. So to make nature a central focus point in all kinds of different processes, from planning to monitoring, management, tender. I will focus on that a little bit after this. So making nature a central focus point in our society. And by doing that and talking about this in this agenda on a high level, we try to prevent that these kind of discussions and definitions are being discussed on the individual project levels. So to make it a little bit more practical, I want to zoom in on an example of offshore wind energy farm. Edward mentioned it, touched upon it before. And it is an example in which we included ecological requirements in the tender process. And it's about the Dutch coast west offshore wind farm located 50 kilometers out of the coast in the North Sea. And the North Sea is one of the most intensely used seas in the world, which has a negative impact, or which has a consequence that nature and biodiversity of the North Sea are under pressure. So with regards to our future plans of expanding offshore wind farms in the North Sea in the future years, and looking at the current state of nature and biodiversity in the North Sea, with this particularly wind farm, it was one of the important questions was how this permit, how this wind farm can actually contribute to the integration of wind energy in the overall ecological system of the North Sea. And what we did, what was being done is within the tender process, criteria for ecological design were included in the tender process. So that the applications were assessed on a couple of different criteria. Of course, financial offer, of course, something with realization, certainty of realization of the wind farm, the experience, the financial guarantees, the contribution to the total supply, energy supply of this wind farm. But also the last criteria was focusing on the contribution of this wind farm to the ecology of the North Sea. And within this criteria, there was actually a lot of room for innovation. So the parties involved were specifically challenged to come up with new ideas, to develop solutions, include new concepts in their plan to contribute to the vulnerable state of the biodiversity at the North Sea. And well, not only were these ecological criteria included in the tender, but it was also given substantial weight. So the tender was designed in a way that half of the points were actually could be gained with these ecological criteria. So which made the winner of the tender depend on who's got the best plan to actually contribute to this ecological focused biodiversity of the North Sea. So it was decisive for the ranking. And focusing on those innovative solutions, they were needed to win the tender, that for sure, but it's also with keep in mind that I think I've heard it before, there's so much we don't know with this kind of scale of wind farms, offshore wind farms. So these innovation solutions are needed, so we can learn and we can gain insight in what works and what doesn't work, and we can make sure that wind energy, offshore wind energy, and the support for offshore wind energy in the Netherlands and well, actually beyond, is being improved. So, so this is with this tender process. It's an interesting example of a policy instrument which included achievable requirements for nature inclusive design, and how ecology and nature can actually play a central role in this kind of energy project. And with our nature, or with our agenda nature inclusiveness, we're working on making nature requirements mainstream and making it default, but we're not there yet. So we just launched it last year. So it's still under construction. The minimal requirements, we can adjust them over time when more insights is gained. And I believe we have one more of those these ecological tenders for offshore wind energy plans, IJmuiden. But after that, we have to we have to take the results into account, and hopefully more of this will follow. So it's definitely not default mainstream here, unfortunately, but well, we are actually experimenting with it and doing it as well. So.
Great. Thanks so much, Flo, for some practical examples from, say, tendering process for offshore wind installation to be built in the Netherlands. Thank you. I think we received a few questions from the floor that were posted in the chat, and then maybe I can just probably read some of those out, and then maybe we can start with, well, this one might be more for Mona, but maybe for others as well. So one question that came is that, is there any experience of public agencies in charge of monitoring bird migration so that it lessens the burden of collecting such information on investors to accelerate permitting process? So you touched a little bit on that, and you mentioned some agencies, but do you want to maybe elaborate a little bit more on this, please? And maybe Flo or Ed may have something to add also.
Yes, thank you for the question. Yes, birds are on the agenda, of course, to be monitored. We have a long history in the United States of monitoring a variety of bird populations and tracking them over time. So the bird banding laboratory, which was started over 100 years ago now, has been collecting information about birds. And you can imagine the technology was very rudimentary when it first started. Basically, it places a band on the foot of a bird, which then when that bird is seen again or found or hunted, for example, by hunters, it is reported back to this bird banding laboratory, and they can start to build basically the story around this bird. Where was it captured? Where was it first banded? And then where was it found again? And so over 100 years now, we've been getting information about birds in North America, where they are. And as technologies are increasing and expanding, like telemetry and using GPS tags and all sorts of other devices that are much more high tech than a simple band around a bird, we've now discovered, new different populations of how some species are more resident, stay in certain areas for longer, whereas others make migrations that are span continents. And so the United States government keeps investing in understanding what's happening with birds, how their populations are changing. A lot of the work is always done in collaboration with academia, with nonprofit organizations that have the mission of protecting birds, simply because we want to bring everybody to the table that wants to contribute. And so organizations like the Cornell Bird Laboratory or Audubon are really important to bring as many resources as we can to the table to do all the work that's involved in understanding birds and understanding how they behave, especially around wind turbines, where they migrate to, what times of year they're there. And so we have a lot to build on. And I'm sure if you talk to our scientists, they'll say there's still a lot that we need to do. And that is true. So yeah. Hope that answers the question.
Yeah, thank you. And I don't know if Flo may have further comments on this from your offshore wind context and the bird migration information. And if I may add, another question that came is, you talked about ecological requirements in tendering process, but have there been generally resistance from investors for this kind of requirement, or is it, more embraced? For example, if investors or people who bid and prepare projects, developers, they need more information, is it the information barrier, or is it extra cost that they expect? So I don't know, maybe you might be able to comment on that as well.
Yes, thank you. So first on the previous question, what we see with this specific wind farm at the Dutch Coast Wind Farm West is we see it as a field lab. So we use it to actually gain data and knowledge on what's happening there with the birds, with the bats, with the species. So it's definitely, yeah, well, they say it's the biggest field lab, or it's going to be the biggest field lab in the world. So we're only just starting to begin to understand the impact of this scale of energy projects on the biodiversity, especially offshore. And the second question in regards to the resistance of the investors, I think what's important here is to be very clear in what are those requirements, what you're asking for from the parties involved, and to involve them early on in the process, to involve all the parties, to inform them up front, and to be very clear in what are those criteria and who's going to assess what, who's responsible for what. And in that way, you can actually prevent a lot of problems later on in the process. So it's a question of be very clear. So what are those requirements? Create a common understanding, a common language of what are you actually asking of these parties. And as far as I know, there wasn't really specific, how do you say, well, there weren't any specific
pushback, maybe you're thinking pushback.
Yes,
or,
thank
yeah.
you. Yeah, thank you. But it is definitely a process of involving everybody and informing them upfront and on time, and giving them also time to come up with this plan. And it definitely asks a lot of creativity from the government, but also from the parties involved. And of course, financial is always an aspect of it. You cannot deny it.
Yeah, great. No, thank you. There's another question, and this is coming from Israel, a colleague joining from Israel. And this is to, I don't know, either one of you or maybe all of you. So the question says, 2 years ago, we surveyed the existing literature on agrovoltaics. So I guess on the farmland, photovoltaics, farm. And then they tried to look at the impacts on biodiversity. And what was found was that there was almost none or non-existent. Is this addressed specifically in this OECD study? So that's probably more for Ed, and maybe other Mona or Flo may have something to add to that. But while, also in the interest of time, maybe I can just add one more thing. So we discussed different, best practices, etc. There's another related question. So what are the most critical policy interventions needed to mitigate the negative impacts on renewable power infrastructure on biodiversity? Can you provide some examples on successful policy implementations that were effectively integrated biodiversity considerations in renewable power? Yeah. Okay. So maybe Ed can start, and then others might add on to that.
Okay, thank you, Kumi, and thanks very much for those questions. I'll try and be brief, but touch on them both. So, yes, solar photovoltaics, agrivoltaics. There we go. Have been used in various contexts, with combined with crops, small fruit trees, small medium-sized livestock. I would concur though with your assessment that there's very little dedicated literature actually looking at the biodiversity impacts. We need to think about both the indirect impacts. So what does integrating solar panels into agricultural land mean for potential displacement? But also what are those on-site impacts? And I think many of the more general findings about solar impacts, I think perhaps hold in agriculture, but there clearly is the inference that by reducing demand for perhaps more biodiversity important land, you are overall reducing the impact. But I concur that there is little in the way of academic literature on that. I do know that the US Department of Energy is actually providing grants to support dedicated work on that, and so we do touch on that in the report in terms of ongoing initiatives, opportunities, potential benefits, and so forth. On the tough question, critical policy interventions. Critical. No. What? I guess there's a guiding principle, or a tool, if you will, for the industry, and that's the mitigation hierarchy. So the idea that it's a sequence of steps. You should first avoid impacts, then what you can't avoid, minimize, reduce on-site, offset. I think that's a critical sort of guiding approach both to planning and projects. If you really want to maximize those opportunities to avoid impacts, then a key policy intervention or rather planning intervention is actually to get the zoning right in the first place, and to integrate biodiversity considerations up front in strategic planning. But there are examples. I mean, translating that into an assessment of effectiveness is quite difficult. But I mean, if you are looking for examples of successful outcomes, reducing electrocution risk by banning poles or putting standards for transmission or distribution lines has been effective. I know in the Czech Republic, Spain, Lithuania, and some other countries. And what the effective solution is will really depend from one country to another, because there are still countries out there that are putting so-called killer poles in place. And so actually banning those would be a very effective measure in that country, but yes, so elsewhere. But really a combination of regulatory, economic, and information instruments is what I would say. Over to
great. Mona or Floyd, would you like to add on this in terms of best practice example? We already heard some. We have 2 minutes left, and then I'm afraid I don't think we can take any more questions. But
I can jump in quickly. Yeah,
okay.
Sure. On the agrivoltaics, I agree. There's a lot of research that's outstanding, or that's just now happening. We have a tremendous biodiversity of, for example, pollinators in the United States. There are almost 4,000 species, and so it's really key to see whether some of the enhancements of the landscape around solar facilities, the vegetation that's planted, whether that can be beneficial to some species. And as you know, the species that are declining, there's special attention put to them. And so if we can plant forbs and different plants that provide habitat to some of the declining species, I think that would be considered, a success. And then for policy interventions, really, some of the best examples come from some of the states in the United States, like California, maybe New York, that set certain standards, regulatory standards, and best practices requiring developers to follow certain protocols in their states. And so, for example, the decision that California had to map out parts of the Mojave Desert and Southern California to really create their own zones where they feel that there's high value habitat that needs to be protected versus habitat or areas that have been disturbed or of lower value. And so maybe looking also at policy levers that are not just at the national level, but at the lower local level also, or state level, are also important levers.
Yeah, no, great. Thanks for that. So already, thanks. I mean, Ed, the report already captured a lot of good examples, but I think there are more lessons to be learned going forward. And then this kind of exchange will be really useful to really enrich our knowledge base collectively. So I think now unfortunately it's time to wrap up. Again, I would like to reiterate my great thanks to OECD's Edward Perry and Mona Khalil, and then Floor Kleemans respectively from the US and the Netherlands for joining us this morning, depending on where you're connecting from. And basically, just in a way of very short summing up, we heard today that without proper planning and management, renewable power can have unintended negative consequences for biodiversity. But also, what's encouraging was that we already have some solutions and good examples how to minimize such negative impacts. And maybe in some cases, not just do no harm, but actually do good, do something that's positive. So this is something, area where we can collectively learn more on. Two key messages, a takeaway for me is that factoring biodiversity into early stages of power sector planning and renewable project design, that's important. And maybe the second, another one is the importance of robust data to ensure that we are learning by doing as we adopt our policies and practices. So again, thank you everybody for the panelists, speakers, but everybody online for participating and posing questions. And then you can access the report that we've been discussing today. I think it's in the chat function, so please do try to access. And then to learn more about the OECD work on biodiversity and also renewable power and everything else related to environment and climate. And I hope that you found today's discussion useful and stimulating, and then looking forward to see you at the next edition on Green Talks Live. Thank you. Bye.